At the beginning of the 20th century, scientists believed atoms were solid spheres of matter. According to the prevailing model, the atom looked something like a plum pudding, with electrons scattered inside a positively charged substance. But one experiment would completely overturn that picture and reveal that most of the atom is empty space. This is Mattermosaic, piecing together the universe, one discovery at a time. The turning point came in 1909 at the University of Manchester. Physicist Ernest Rutherford and his colleagues designed an experiment to probe the structure of the atom. The experiment was carried out by Hans Geiger and Ernest Marsden, who fired a beam of alpha particles toward an extremely thin sheet of gold foil. Alpha particles are positively charged particles emitted by radioactive elements. Because they are relatively heavy and energetic, scientists expected them to pass straight through the thin foil with only slight deflections. Most of them did, but a small fraction behaved in a shocking way. Some particles bounced back at large angles, and a few even reversed direction entirely. Rutherford later described the result with amazement. "It was," he said, "as surprising as firing a large artillery shell at a sheet of paper and seeing it bounce back." These unexpected deflections revealed something profound about atomic structure. If the positive charge of the atom was spread evenly throughout the atom, as earlier models suggested, such dramatic scattering would be impossible. Instead, the results indicated that nearly all the positive charge and mass of the atom were concentrated in a tiny central region. Rutherford proposed a new model of the atom in 1911. At its center was a dense core, which he called the nucleus. Electrons occupied the surrounding space, moving around this nucleus. The nucleus was incredibly small compared with the size of the atom. If an atom were the size of a stadium, the nucleus would be roughly the size of a marble at the center. Yet this tiny region contains almost all the atom's mass. Later discoveries expanded this picture. In 1917, Rutherford identified the proton as a fundamental nuclear particle. In 1932, James Chadwick discovered the neutron, explaining how atomic nuclei could contain mass without additional electric charge. The discovery of the nucleus transformed physics. It opened the door to nuclear chemistry, particle physics, and modern atomic theory. It also led to technologies ranging from nuclear energy to medical imaging. Most importantly, it revealed that matter is not solid in the way we once imagined. Atoms are mostly empty space, structured by tiny but powerful centers of mass and charge. From a thin sheet of gold foil and a beam of particles, scientists uncovered the hidden architecture of matter itself. This is Mattermosaic, piecing together the universe, one discovery at a time. If this exploration changed how you think about the atoms making up the world around you, share it with someone curious about the experiments that reshaped our understanding of reality.